Alright guys, so we have the 6.5 notes today. Starting off with this first problem, it's asking us to find the missing sides. It's asking us to find the perimeter, and it's asking us to find the area of the triangle. So it tells us at the beginning that ABC is similar to DEF. So that means AB and DE are proportional, BC and EF, and AC and DF are all proportional to each other. We have AB is AC is 8, CB, well, AC, if we use AC, we could figure out what the missing one is, right? DF is its corresponding part. We just need to find which one we have both of. So we have both CB is 6 and FE is 3. So using these two, we could see they both go right here. This is going to be the scale factor. Let me adjust my screen really quick. Alright. So it's going to be 6/3, which is just 2. So that means that the triangle on the right is twice the size of the triangle on the left. Sorry, got that backwards. The triangle on the left is twice the size of the triangle on the right. Sorry, it's early in the morning right now, so anything from the right triangle, we would just double to get to the left triangle. So this would be 5 times 2, which is 10, and to go from left to right, we would divide. So this one is going to be 8 divided by 2, which is 4. So there are our lengths. The perimeter is all the sides added up. So the perimeter of ABC is going to be 8 plus 6 plus 10, which is 24. The perimeter of DEF is going to be 4 plus 3 plus 5, which is 12. And then finally the area of a triangle is 1/2 times base times height. So for area of ABC, that's going to be 1/2 times the base is 6 and the height is 8. They are perpendicular to each other. They form a right angle. That's how I know it's those two are the base and the height, and not the length of 10. So this is going to be 24 units squared. And then the area of DEF is going to be 1/2 4 times 3, which is going to give us 6 units squared. Okay. There is, a pattern here that we're going to talk about in a second. Let's take a look. Okay. So the scale factor is the same as the ratio of sides. So in this case, if we're going from, it doesn't specify whether we're going from small to large or large to small, so we can just say it is 5 to 8. The perimeter of the first square would be, we'll say that this is number 1, this is number 2. Is going to be 5 times 4 because it has 4 sides and they're all 5. So this is going to be 5 times 4, which is 20. This one will be 8 times 4, which is 40. And then their ratio of the ratio of perimeters would be their perimeters set up like we did up here, right? So this would be 20 to 40, which simplifies to 5 goes into 5 goes into both of those. 5 goes into 24 times, and 48 times. And this is 1/2. Yeah, 4 goes into both of those. 1 to 2. Something's wrong here. 20. Oh, I made a mistake. We have to back up. 8 times 4 is not 40, it's 32. So 20 to 32, that simplifies down to 5. 4 goes into both of those. 4 goes into 25 times, and it goes into 32 8 times. The reason why I was able to recognize that I made a mistake was because the scale factor and the ratio of perimeters are supposed to be the same thing. So notice that they're both 5 to 8. If we put them the other way, it'd be 8 to 5. Doesn't really matter. So now let's talk about the area. The area of a square is just one of the sides squared. So that's 25. And then the area of number 2, square number 2, is going to be 64. So the ratio of areas is 25 to 64. This doesn't simplify. You would want to check just in case, but the only things that go into 25 are 5 and 25, and neither of those go into 64. So this is simplified. But if you look, it is just, our scale factor is 5 to 8, right? If you square both of those numbers, you get 25 to 64, which is our area, our ratio of areas. So the ratio of areas is always going to be the scale factor squared. So the big takeaway here is that the scale factor is equal to the ratio of ratio of sides, which is equal to the ratio of perimeter. And here's the formal definition. So polygons are similar when their corresponding angles are equal and their corresponding sides are in the same proportion. Just as their corresponding sides are in the same proportion, the perimeters and areas of similar polygons have a special relationship. The perimeter of similar polygons, the ratio is m to n. Let me circle that better. I gave it a shot. Then the ratio of their perimeters is also m to n, so it's the exact same. And then the area of similar polygons, if the ratio of two polygons is m to n, then the ratio of their areas is m squared n squared. Right? So again, this is your scale factor right here. So all these ones are asking you to do is find the scale factor, which in this case would be 4 to 3, which is also the ratio of perimeter, and then find the ratio of areas, which is going to be 4 squared and 3 squared, which is 16 to 9. So again, this is perimeter, and this is area. Same here. The only thing is you have to pick, with squares it's easy because you can't pick a wrong side, right, because they're all the same. With other shapes, you have to make sure you align the correct length. In this case, we have both of the bases, so we're going to use the base. So the ratio of perimeter is just going to be 5 to 10, which means that the ratio of area is going to be 25 to 100, or 1 to 4. The perimeter could also be simplified to 1 to 2, and then if you square that, you would get 1 to 4. So this one's just saying we could have the ABC triangle on top and the EFG triangle on bottom, or we can have it vice versa, right? We could have EF on top, AB on bottom, FG on top, BC on bottom, EG, I'm going to erase this now, EG on top, AC on bottom, right? Same thing. One is small to large, the other is large to small, depending on what the question's asking or which way you're trying to go. No matter what, though, each ratio is equivalent to the scale factor. And the scale factor is equal to the ratio of sides, which in this case, we just have to figure out which ones we're going to use. I'm just going to use the first one I see, which is AB, and I know AB and EF are the same. So ABC is on top, so it's 6-2, or on the left, which is 3-1. And that is not only the ratio of sides, it is also the ratio of perimeter. And then the last thing if this asked, the last thing we would have to do is ratio of area would be 3 squared and 1 squared, so 9-1. It doesn't ask that, but it's really quick, really simple. Just square both numbers and you have the ratio of area. So this is telling us that the perimeter of triangle ABC is 12 and that these two triangles are similar. Find the perimeter of XYZ of the scale factor of ABC. So this is ABC and this one is XYZ. You could also do it like this. This one's 2, this one's 3. So there's your scale factor. So it's 2/3 is equal to ABC is the given one right here. So that goes on top. We're trying to find the missing one, which is the perimeter of XYZ. So now we have our proportion set up. This whole chapter, you're just trying to set up proportions, right? Cross multiply, divide. This is going to be 36 equals 2x. Divide by 2, and we get x equals 18. And if you want to check your work, you just plug in the 18 over 12 over the 18, and what does that simplify down to? In this case, right, 6 goes into both of those, 2 times for the 12, 3 times for the 18, and you've got 2/3. It's the same as the scale factor. Again, you have ABC. You're told that these two triangles, ABC and XYZ, are similar. We need to find the scale factor, which is also the ratio of perimeter. So all we need to do is put the two perimeters over each other, well, one over the other. In this case, this one's on top, this one's on bottom. So it's going to be 27/15, and I just need to simplify this problem, which would be 9/5. And there we have it. It's quite a lot to this one. Two rectangulars are similar, and if their scale factor is 3-5, what is the ratio of areas? Well, it's just going to be the scale factor squared, so 9/25. What is the area of the smaller rectangle if the larger rectangle has an area of 50 meters squared? So we already have this. We have the ratio of areas. So like we did up here with this one, you're going to set up a proportion. You're going to cross multiply and divide. When you're finding an area, you have to use the ratio of areas instead of the scale factor. So I'm just going to do 9/25. It doesn't matter if you do 9/25 or 25/9, as long as you know which one you're comparing it to. The larger rectangle is 50. Well, 25 is bigger than 9, so that means 50 has to go on the bottom. And we're trying to find x. Okay, so cross multiply and divide, you get 450 equals 25x. Divide by 25. And x is going to be 18. If the denominators go into each other like that, or the numerators do, it doesn't matter. Like 25 goes into 52 times, you could just double the fraction in this case. So now we're given the ratio of areas. Find the ratio of sides. So we're going backwards. In order to get the ratio of areas when you have the scale factor ratio of sides, you square it. In order to go the other way, we would just square root both of them. So square root 25, square root 64, we're going to get 5/8, which was the original problem at the beginning of this. And then the ratio of the perimeters is the same thing as the ratio of sides, except for it wants it large to small, so we're just going to rearrange it 8 to 5. And now we're done. Two triangles are similar, and the ratio of each pair of the corresponding sides is 2 to 1, so one is twice the size of the other. Which statement regarding the two triangles is not true? Assume each ratio represents the larger triangle first. Okay, so the ratio of areas is 4 to 1. Well, if we square 2 and we square 1, we get 4 to 1, so A is true. So we're not going to pick that one. The scale factor is 2 to 1. Well, the scale factor is the same thing as the ratio of sides, which is what we're given, so that's identical, so that's also true. Perimeters is 2 to 1, which again is the same thing as the scale factor, so that one is true, which only leaves D left. Their corresponding angles have a ratio of 2 to 1. Well, angles have to be congruent. They have to be completely identical. They can't be doubled. If you think about comparing two triangles that are similar, this one has 180 degrees, and if the larger one was double, that would mean it'd have a 360 degrees, but that's not true because all triangles, the three angles add up to 180. So this one is the answer because it's not true. The ratio of areas of a square A to square B is 16 over 25. If the area of square B is 100, so B is on the bottom, what is the length of a side of A? So we need to find the area of A and then square root the area once we've found it. So we already have the ratio of areas. We are looking for A over the area of B, which is 100. Cross multiply. You're going to get 1600 is equal to 25x, and then we just divide. This is going to be 64. But this is not our answer. This is the area of A. So if we want to find a side length, all we have to do is take 64 and square root it, and we get our side length. So 8 is the correct answer. A school playground is similar in shape to the community park. You can mow 250 square yards of the grass in 15 minutes. How long would it take to mow the grass on the playground? Let's see. So we need to find the area of the playground. So we have a side length of each, 32 to 20. We need to find the area of this ratio of areas, so we square both of these. I need to grab a calculator really quick. Pop in 32. Squared is 1024. 20 squared is 400. And now that's our ratio of areas. That we're going to set up a proportion to solve for the area of the playground. The big one's on top, so 2560 over x, cross multiply, we're going to get 1024x equals 400 times 2560. That's a big number. So it looks like we have 1,024,000. Divide. That goes into it. It looks like somewhere around 1,000 times. Yep, that was exactly right. So again, this is the area of this one. So if they can do 15 minutes for every 250 yards, we just have to divide, because this is yards squared. So we just have to divide that by 250. So 1,000 divided by 250 is going to be 4. So there's 4 intervals that we have to do. So each one of those 4 takes 15 minutes. So times this by 15, and that takes 60 minutes or 1 hour. All right, guys. Hope the video helped. If you were here or weren't at school or for whatever reason missed this class period. But that's it for this section, and that's it for this unit. So good luck on the test.